Hi, and welcome to this demo on containers on Amazon GameLift servers. I'm Juha Jantonen, I'm a Principal Solutions Architect with the AWS for Games team. So we'll start off by showing you the actual sort of demo in action. So I'm spinning up 4 clients here. I'm using the standard third-person sample game for Unreal. And I've integrated it with the simple API. So the clients are calling an API to request a game session. They will receive things like the IP and the port of the session, and they will connect using the standard Unreal netcode to this session and start moving around a little bit so we see them connected to the same world. So you can see all of these 4 clients connected to the same session. They received the IP, the port, the player session ID, and did a UDP-based connection to the server. We'll just keep those running and talk you through the architecture a little bit. So there's 2 key components here. We have the actual container starter kit. It includes a deployment pipeline that we deploy with a CloudFormation template, and also the Amazon GameLift fleet that is deployed as part of that stack. And then we have a simple API that we're using in the demo. So there's a REST API for requesting game sessions. So we start with the starter kit. There's an Amazon S3 bucket where we upload the game server build. This includes basically copy your existing Linux binary. Typically it's your Unreal server or Unity server, any other game server. You copy it to a certain folder, and then it also contains a sidecar process that communicates with GameLift for you. Then you go to AWS code build, you hit start build, and the build process starts. So in the build process, we build the Go sidecar that sort of manages the GameLift communication for you. This means that you don't need to bring in the GameLift server SDK to your actual server in the beginning. And then it will bring over your game server build and also create a container image for you that is then uploaded to Amazon ECR. So this is the container that is running on the GameLift service. Then the code build setup will create a new deployment against the Amazon GameLift fleet, and the GameLift fleet will then download the new container image and sort of set up the new version of your game server build. This is done in a rolling fashion, so if you have existing sessions against the fleet, they can keep going, or you can create sessions even during the deployment. There's a few ways you can sort of manage how that deployment happens, and then once the new version is up, the sessions are created against the new version. On the API side, we have Amazon API Gateway. We have a simple REST API, just a single GET endpoint to request a game session against a specific location you define, which triggers an AWS Lambda function. And in the Lambda function, we're using the AWS SDK to sort of either create a session or sort of find an existing session with the GameLift APIs. And if we don't find one, create a new one and then join that session by creating a player session. And the player receives the IP and the port, and we'll just connect over Unreal netcode to the game server process directly. Just briefly on the API. So this is the API endpoint. It's a sort of very simple API for requesting game session by defining a specific location you want to host. So GameLift fleets can be hosted in multiple locations around the world. It's easy to add locations as you need. So if you added a new location, the API would automatically support that new location for creating new sessions. And here's an example of the response. This is the same thing you saw in the Unreal client side. So there's player session ID, IP, and port, and some other information here. So if we move on to the GameLift side, so in the console, you can see that we have the session created that the client's connected to. You could go to the session and get some information of that. Some other interesting information here could be, for example, locations. So if we wanted to host closer to players in another region, we could add it here. So we could have like a location in Europe, for example, EU West 1 for our European players. We could add it here, and then GameLift would automatically copy that game server build to that region, set up your fleet, set up your EC2 fleet that GameLift manages for you, and start hosting in that region as well. On the metrics side, there might be a few interesting things here. So if we look at activity metrics, you can see like what is the current active count of instances, what is the count of available game sessions. So you see I've recently created a few sessions here, so that went down. You can see the current player sessions created against the game sessions and all kinds of information like that. On the container side, we can see things like CPU utilization on the instance level, CPU utilization on the container level as well, memory utilization, network in and out. So we can sort of monitor how the environment is behaving, and should we pack maybe more game servers to an EC2 instance to to better utilize those resources. Also, the log output of the game server as well as the sidecar process that manages the game communication, they are both sent to Amazon CloudWatch logs by default. So if I went to CloudWatch logs, I would see the log output of each and every game session separately for any debugging purposes I have. The container starter kit, you can get started pretty quickly. Just clone the repository. You can bring in any existing game server builds. So this could be Unreal, Unity, Godot, C++, Go, whatever you happen to have. It can be any binary that runs on Linux. You just configure a few things in the starter kit. So you define the name of the binary, where it's located, the port you're using for the connection. Then you deploy that CloudFormation stack that I showed for the deployment pipeline, upload the game server build, and run build. So this shouldn't take you more than 30 minutes. And then you can start configuring to your needs, like adding more locations, configuring the scaling, modifying maybe the deployment pipeline to your needs, modifying the Docker environment, because we're running a container, so you can configure any additional tools you want to install. But this is a great starting point and gets you started in 30 minutes.